Section C, Science Paper 1, Physics. So there are 3 questions in this section. You are required to answer any of the 2. So how do you choose the questions? You choose the questions where you're going to score the highest marks. So you need to go through all the questions. Then you choose where you're going to score the highest marks. So C1, Part A, Figure C1.1 shows results of velocity and time recorded for an object that was dropped from a certain height on the surface of the moon. So this is the table of values. So part 1, plot a graph of velocity against time, 4 marks. So the first thing you need to identify the axis. So in this case, velocity against time. So velocity, it will be on the y-axis. Time, it will be on the x-axis. From there now, you are going to choose a suitable range. A suitable range, the scale. Okay? Then from y-axis, we have 0 to 8. And x-axis, we have 0 to 5. So you need to choose a suitable range. So this is time in seconds. Don't forget to label the axis. So this side we have velocity in meters per second. So don't forget to label the axis. So you need to choose a range that will give you half or more than half of the graph paper. So in this case, from the x-axis, the range is 0 to 5. When I start from here, let me say 0. This is our 0. 0, 1, 2, 3, 4, 5. My graph is going to be small. Okay? So I need to make sure that I have 3/4 graph. So now from here, I can say this is 2 centimeters, 4 centimeters. What about 4 centimeters to 1 unit? That is 1, 2, 3, 4, 5. Okay, that's good. Then to the y-axis, it is 0 to 8. So there I can have 1, 2, 3, 4, 5, 6, 7, 8. There is no problem. So for the range, it is going to be the scale x. It will be 4 centimeters to 1 unity. Then for the y-axis, it will be 2 centimeters to 1 unity. So there, so 2 centimeters, 4 centimeters to 1 unit. So that is where our 1 is. 2, 4 centimeters, 2, that is 3, that is 4, and we have 5. That is our 5. Then to the y-axis, to the y-axis, to the y-axis, we have 2 centimeters to 1 unit. So that is 1, 2, 3, 4, 5, 6, 7, 8. So don't forget as well to put up a title. So the title, it is velocity time graph. Velocity time graph. From there, you now plot. Remember, when we are plotting, it is x, comma y, x, comma y. So you start with time, then you go to velocity. So we have 0, 0, 1, 1.6, 2, 3.2, 3, 4.8, 4, 6.4, 5, 8. So 0, 0. So this is 0, 0. Then we have 1, 6.4. So x-axis, which is time, we have 1, 1.6, 1. So 1, 1.6. So 1.1, 1.2, 1.3, 1.4, 1.5, 1.6. So we have 1, 1.6. So that is 1.6. Then we have 2, 3.2. So 2, 3. 3.1, 3.2. So that is 3.2. So that is 3.2. Then we have 3, 4.8. 3, 4. That is 4. So 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, 4.7, 4.8. Then we have 4, 6.4. So 4, 5, 6, 6.1, 6.2, 6.3, 6.4. So that is our 6.4. Then the last one is 5.8. 6, 7, 8. So from there, you are going to join the points to draw the best fit line from the origin. From the origin. So that is the best fit line. So part 2, use the graph to determine the time when velocity was 4 meters per second. So what is the demand of the question? The demand of the question is to use the graph to determine time. So we need time when velocity was 4. So we will go on the graph where velocity is 4 meters per second. So this is velocity. So this is where velocity is equal to 4 seconds. So I'm going to draw a dotted line up to where the graph is, and I'll come down to find the time taken. So when velocity is equal to 4, so when velocity is equal to 4, so you need to put up a dotted line when velocity is equal to 4, so to where the graph is. So where velocity is equal to 4 and the graph, they are intersecting. You come on the x-axis where time is. So you continue with a dotted line. You continue with a dotted line. Then what is the time taken? So the time taken is this is 2 and this is 3. So how are we counting? So trependa shanu tubokosi utu. So for me to have 2 here, 3 there, it means that to tutbokos tubidi twalependa mo 0.1. So if this is 2, 1, 2, 2.1, 1, 2, 2.2, 1, 2, 2.3, 1, 2, 2.4, 1, 2, 2.5, 1, 2, 2.6, 1, 2, 2.7, 1, 2, 2.8, 2.93. So here it is 2.5. So when velocity is equal to 4, time is 2.5 seconds. So time is equal to 2.5 seconds. Part 3. So part 3, calculate the gradient of the graph. So we already have the points. These are the points. So from these points, you can pick two pairs of coordinates for you to calculate gradient. Remember that gradient in the same line is the same. Okay, so you can pick any of the two pairs. So I'll pick 1, 1.6 and 2, 3.2. So gradient is equal to y1 minus y2 over x1 minus x2. So remember those two pairs of coordinates. We have 1, 1.6 and we have 2, 3.2. So mind you, you can use any of the two coordinates, okay, of the graph. So these points that we have given, these are the points that are giving us the graph. So remember that a coordinate is x, y, a coordinate is x, y. This is x1, y1, x2, y2. So gradient is equal to y1 is 1.6 minus y2 3.2 divided by x1 is 1 minus x2 is 2. So gradient is equal to 1.6 minus 3.2. So we have negative 1.6 over 1 minus 2, it is negative 1. So gradient is equal to negative, negative goes, it is positive. 1 into 1.6, it is 1.6. So there you need to include the units. So remember the graph that we have. So on this graph, so this graph, it is a velocity time graph. So the result that we have, it is acceleration. So what we have calculated here, we have just calculated acceleration. So when we plot the graph of velocity against time, so the result, the quantity that we have here, it is acceleration. So the units that I'm going to add there, they are for acceleration. So we have meters per second squared. Part 4. What does the gradient of the graph represent? So the gradient of the graph, it is representing acceleration. Okay? So velocity against time, the graph, it is representing what? Acceleration. Remember the definition of acceleration. Acceleration, it is the rate of change of velocity. So the rate of change of velocity, that is acceleration. In this graph, we have seen the change of velocity with time. The change of velocity with time. Part B, state the principle of conservation of energy. So what does the principle of energy conservation states? So what does the conservation of energy states? So conservation of energy, it says that energy cannot be destroyed, it cannot be created, but it can only change from one form to the other. That is what we call conservation of energy. It states that energy cannot be created or destroyed, but can change from one form to the other. So that is conservation of energy. Conservation of energy, it says that energy cannot be created or destroyed, but can change from one form to the other. C2, figure C2.1 shows a waveform indicating voltage produced by a generator. So that is a wave. So we have this side, we have a voltage in volts, that is the amplitude. Then we have time in seconds. So part A, what type of electricity is produced by the generator? So remember that we have two types of the generator. We have what we call the AC generator and we have the DC generator. So now this type of a wave that we have, it is the AC generator. So now the electricity that it is producing, it is a AC, which is a alternating current. Alternating current. Part B, determine the maximum voltage produced by the generator. Okay, so the maximum voltage. So we have the maximum voltage. This is how the wave is moving. So the highest point. So the highest point it is reaching, it is in 5. So you go on the highest point of the wave. So that's where it is starting from. So the highest point of the wave, it's this one. So the maximum voltage that it is producing, it is in 5. Part C, state two ways in which the electromotive force, EMF, produced by the generator can be increased. So how do we increase the electromotive force, which is the voltage as well? How can we increase it? Number one, we can increase the electromotive force by using a stronger magnet. A stronger magnet, we can say by using a permanent magnet. Number one, by using a stronger magnet, okay, or by using a permanent magnet. Number two, by increasing the speed of rotation of the coil, by increasing the speed of rotation of a what? Of a coil. Number three, also by increasing the number of turns of the coil, by increasing the number of turns of the coil. Part D, part D1, define a transformer. A transformer, it is a device that varies the voltage of an alternating current supply. That is what we call a transformer. A transformer is a device that varies. So remember, vary, it means to change. The voltage that varies the voltage of an alternating current, which is AC supply. So that is called a transformer. D2, draw a diagram of a setup transformer. So you have 3 marks. Draw a diagram of a setup transformer. So you have 3 marks. So there are two types of transformers. So we have a step down transformer and a step up transformer. So now what's the difference between the two? So a step up transformer, it is used to increase the voltage. A step down transformer, it is used to reduce the voltage. Now, the step up transformer, it has more number of turns on the secondary than on the primary. On the step up transformer, voltage of the secondary coil is greater than voltage on the primary coil. So let us draw that one. So you need to ensure that as you are drawing, you draw the symbol of a transformer. Okay? So remember that for the step up transformer, it has more number of turns on the secondary than on the primary. So this is a symbol of a transformer. So there we have coils. We have more number of turns on the secondary. So that is the iron core. This is the secondary coil. Secondary coil. So as you can see, it has more number of turns than on the primary. So this is the primary coil. So don't forget to label. You have to make sure for you to score full marks. Label. So this is the iron core. This is the secondary coil. This is the primary coil. You need to make sure that you draw properly and you label properly. Very important for you to score full marks. Part E, explain why it is cheaper to transmit electrical power at a higher voltage than at a lower voltage. So the reason is very simple, because it reduces power losses through it. Because it reduces the power losses due to it. F, what does it mean to laminate the iron core of a transformer? It is coating the iron core with an insulator. So that's what it means to laminate the iron core. C3 part A1. Define nuclear fusion. Nuclear fusion, it is the joining together of small nuclei into larger nuclei, producing energy in the process. So that is nuclear fusion. So part 2, state 2 similarities between nuclear fusion and nuclear fission. So the similarities is that both processes, they involve the release of energy. So both processes result into the release of energy. That is number 1. So both processes, they are unstable radioactive nuclei. Both processes are unstable radioactive nuclei. Part 3, write an equation for the reaction of hydrogen and hydrogen 3. So this is hydrogen 2 and hydrogen 3 to produce helium. So write an equation. So this equation, it is the one that we call thermonuclear equation. So this type of an equation, we call it thermonuclear equation. So in this case, we've got hydrogen 3 plus hydrogen 2. So what we are going to have, it is helium. It is helium plus a neutron. In the end, energy will be released. So 1 plus 1, that is 2. 3 plus 2, we have 5. But in the end, 1 neutron is released. So 1 plus this, we have 5. So that is the neutron that is released plus energy. Name a device that can be used to measure nuclear radiation. So number 1, we have Gilgamura tube. Gilgamura tube. Number 2, bubble chamber. Number 3, we have photographic film. Number 4, we have spark counter. B2, which radioactive emulsion is not diffracted by an electric field? So that is gamma rays. So gamma rays are not diffracted by electric gamma rays are not diffracted by magnetic fields. See, a radioactive sample of mass 200 grams has a half-life of 8 days. How much of the sample would have decayed after 32 days? After 32 days. Here is the formula that we have to use. So we have remaining mass is equal to original mass times 1/2 time taken over half-life. So that is the formula that we are going to use. So we have any R, that is the remaining mass. Then we have NO, that is the original mass. We have T, it's a time taken. We have half, that is the half-life. That is what we have. The original mass, which is 200. So the original mass, it is 200 grams. We have the half-life. Half-life, it is 8 days. We have the time taken. The time taken is 32 days. Okay. So what do we want? So first of all, we are going to find the remaining mass. When we find the remaining mass, that's when now we'll come and find the mass that was used. So in this case, we are going to find the remaining mass. So the original mass, it is 200 grams times 1/2. Time taken, it is 32 divided by half-life. Half-life, it is 8. So simple. Remaining mass is equal to 200 times 1/2. 8 into 32, that is 4. So the remaining mass is equal to 200 times 1/2 to the power 4. We have 1/16. So there we have the remaining mass is equal to 200 divided by 16. So the remaining mass is equal to, we have 12.5 grams. This is the remaining mass. But now the question is demanding for the mass that was used. So the mass that was used, is equal to original mass, it is 200 grams, minus the mass that was the mass that remained. So the mass that remained, it is 12.5 grams. So we have 187.5 grams. This was the mass that was used. So the last part D, state one way of handling radioactive materials safely. So number one, wear the proper protective equipments. Wear proper protective clothes. That is number one. So wear proper protective equipment, which is PPE. Then number two, so you store the radioactive sources in a thick reed box. Store radioactive sources in a lead box. In a lead box. Number three, do not bring the radioactive source close to your eyes. Do not bring the radioactive source close to your eyes. So in other words, you don't need to handle radioactive materials with your bare hands. So instead, we need to use the tongs for us to handle radioactive materials.